Hello everyone, thank you for the time and opportunity has given to me. Before I present our research result, let me introduce myself. I'm Oktaviani Ajung, a 7th semester chemistry student. I will present the result of research with title Surface Modification of Paper-Based Analytical Device with Polymer Inclusion Film as Optical Sensor for Detection of Ferric Ions in Water. Along with the rapid growth of the human population and the development of increasing industrialization, there are various concerns due to the negative impact it causes, such as the increase in heavy metal concentration in the aquatic environment due to the waste disposal that has not been maximally processed. These heavy metal ions have a tendency to bioaccumulate in bioorganisms and enter to the food chains. It will then cause various health problems, namely the damage to vital organs such as the liver, kidneys, and brain. Seeing this problem, a practical method is needed to monitor heavy metal concentration in the aquatic environment directly in the field. Approach methods that are often used are atomic spectroscopy and spectrophotometry. However, this method also has the disadvantage that it cannot be applied directly in the field. In the last decade, micropet or microfluidic paper-based analytical device has become an attractive option for heavy metal detection in water. Micropet has the advantage of portability, economy, and environmental freelance. Micropet consists of two areas, hydrophobic area and hydrophilic area. Analysis with micropet is based on reagent deposits onto the reaction zone and the reagent will react with the analyte producing measurable colors and this change is then detected using specific smartphone using the color picker application. The reagent deposits method is the often used is the absorption method. However, this method has the disadvantage that the reagents are easily separated from the surface of micropet. Therefore, one way to overcome this weakness is to modify the reagent deposits process that will be accrued on the hydrophilic zone of micropet. Through the research, the reagent will be encroached into a polymer inclusion film or PIF solution. PIF is a transparent solution consisting of extractant that bind the reagent and supporter polymer that maintain the stability of micropet. The extractant and supporting polymers used were DIPA and PVC respectively. Furthermore, the preparation of the PIF solution itself was carried out by weighing the composition of PIF, colorimetric reagents, and reductant, then mix in the Durand lab flex container, then stirring for 3 hours at 40 degrees Celsius. The solution is ready to be applied for analysis. For the research procedures and analytic and the results, first the sign and fabrication of micropet, carried out by Wattman filter paper number 1, made a hydrophilic zone or reaction zone with diameter of 0.5 cm and then made a hydrophobic zone using acrylic paint. After that, the micropet is laminated and ready to be used for analysis. Analytical procedures and optimization. First, optimization of PIF components. The goal is to obtain a good optimum composition by forming a transparent layer that is able to encapsulate the reagents. PIT with composition of 60% PVC plus 40% DIPA was choosing the optimum composition. And the next, reagent composition and others, the goal is to see which composition give the best color intensity and absorbance value. From the table, it can be seen that the optimum composition of phenanthrolene reagent is 20% PIF volume of 30 microliters. Complementary color is blue, reaction time is 20 minutes, sample volume of 35 microliters, and pH of 4.5. Next, standard curve. The standard curve graph is a graph of the relationship between concentration and absorbance of the standard method, namely UV spectrophotometry and micropet. The graph proves that the concentration and the absorbance are directly proportional, with the correlation coefficient of the two being 0.998 and 0.999 respectively. This is indicate that micropet can be used to detect the presence of ferric. Selectivity test. The aim to see the confounding effect of some cations on the determinant of ferric ions concentration using micropet. The limit of variable confounding effect is plus minus 5%, which means that the present recovery range of micropet should be between 95 to 105%. The result can be seen in the table, which shows that the ratio of confounding effect of each cation doesn't exceed plus minus 5%. Therefore, micropet is said to be good because it's only selective for ferric. Stability test. In determining the stability of micropet, two storage variants were made, namely airtight and non-airtight. This was done for 7 consecutive days, and the graph showed that the airtight micropet has a higher absorbance compared to non-airtight micropet. And the developed micropet has storage stability until the 5th day. Determination of ferric ions concentration in water. Determination of concentration was carried out by comparing the measurement result using micropet with the measurement result using UV as a standard method. From the table, it can be seen that the concentration of micropet and the standard method do not differ too significantly. This proves that the micropet is able to detect the presence of ferric ions in water. Next, validation test results. Based on the table of validation tests, the accuracy, precision, present recovery, determination of limit of detection or LOD, and limit of quantity or LOQ values of the micropet didn't exceed the specific standard limits. And the next, comparison of micropet with PIF and micropet without PIF. The result shows that the micropet with PIF is better than micropet without PIF, because micropet with PIF without PIF, because micropet without PIF, the value of accuracy, precision, and recoverability exceeds the maximum standard limit. This is due to error caused by the release of reagent during the process of making storing micropet. And the last conclusion, PIF component can be used to modify the surface of micropet. The optimum composition of PIF is 60% PVC and 40% DIPA, obtaining a portable micropet and able to detect ferric ions in water. And the last, I want to say thank you to all those who have helped us get to the end of our research. Thank you.
Sudah.